Hello everyone, it's February 9th. Just relived on YouTube some of the best goals in history. It was Juninho's free kick of multiple curls. I call it a knuckleball. But that one was, I think, curved at least 2 times. Somebody said 3 times. That one was ridiculous. And then Roberto Carlos, 1997 against France. Most ridiculous free kick. And then David Beckham, World Cup. Was that 2002 World Cup against Greece? Yeah, I just watched all those. It gave me very emotional. Yeah, that was the free kick last minute. Got England into the World Cup. And then Ibrahimovic against England. I just say England happens a lot in this list. I don't know, was that a friendly or I don't remember, but that was his bicycle kick. It was like, I don't know, 30-yard bicycle kick. Ridiculous. And finally, of course, Diego Armando Maradona, 1986, in Mexico. Estadio Azteca against England. 2 goals, okay, in one game. Hand of the God, and then also the goal of the century. Commented by Victor Hugo Morales. It's just, sometimes I do this type of thing. Just go through all these goals and just relive all those moments. I don't think I watched any of them live. Maybe, I don't know, maybe the Roberto Carlos one, maybe I watched it live. But most of them, no. I never watched them live. But even just reliving all those, I've watched them many, many times. But every time you see that, you just feel something, You feel something in you. That's just really, really. Alright, I remember this problem. Palindrome substring, it has a smart solution of doing. Is that the one that has a smart solution of findings that you can do like ON instead of ON squared? I think that's the one, but I'm not gonna really go for this. Have a smart way of manipulating, because if you know a palindrome already, you can take advantage of it when you do the next comparison. All right, let's just do it the normal way. All right, the number of palindromic substrings in it. And I believe if we do it regularly, I think that was dp, right? If we do it regularly. Number of palindrome. So I say up into here, the total number of palindrome I know, ending at here. Total number of palindrome ending at here, total number of palindrome ending here. And what we want to do is add them all together, right? So I want to know the total number of palindrome ending at this one. So what I need to do is the total number of palindrome ending at this one. Well, I need to find where the previous one is a C, right, in this case. So I can have a list with all the C's. And then, right, and then I need to know if the thing in the middle, if it's a palindrome. That doesn't sound like the right way. Or, oh, no. I have a list of palindrome ending at this one. Right, I have a list of palindrome ending at this one. And then we simply just check if the one in front is a C. If it is, we have a new palindrome. If it is not, then we don't. Right, then we don't. So we just need to have a list of indices. That from that index to this is. So every one by itself is, right? And then we have to look to the one in front. And the one in front, if it's equal, then we have another one. These are the 2 special ones. And for here, it's always going to be by itself, right? By itself. And then we probably find something else. And if it's by itself, then we basically say have to check this one in front, right? Okay, so let's give this a shot. Yeah, I'm not gonna try the other method, but I know there is. I'm pretty sure it's this problem, right? There should be another method that exists. Okay. All right, let's do this. So we need a DP table, which honestly is not a DP table, which is a list of lists, right? So what we need to do is to have a list of integer, right? And we call this a DP, right? We call this a DP, and then for each one, right? For each one, we are going to put one in it, and now we go to the one. So we say for I 0I s plus size or line of size s plus. I don't have size. I don't have length. Yeah. Plus. Okay. DP dot append add a new array list. Okay, so that's the first one, and then we will say DP dot is that get DP dot length. No, length or size minus 1 is the last one. You know what? I think it would be easier to do this. We say list integer current equals new array list. Okay, and then we don't do this, we don't do this. We simply say current dot add I by itself, right? And also need res is 0, right? And then we need to go if I minus 1 is larger than 0, larger equal to 0, right? Then we say for j, right, int j of dp. Actually, because I just need dp to have something. Actually, this is not as intuitive. We should say if dp dot is empty. If dp is not empty, then we can do dp dot get dp dot size minus 1. Okay, so we get every single, which is just the thing, right? We get every single thing that is the indices that will cause the previous one to be the palindrome. Then we say if j minus 1, right, large equal to 0, and s dot char at j, actually no, j minus 1, right, s dot char at j minus 1 is equal to s dot char at I, right? If these two are the same, then I say current dot add j minus 1, because that's a palindrome. We find a match and everything in between is good, right? And then we do that, and then the last we say if I minus 1 is larger than 0 and s dot char at I minus 1 is equal to s dot char at I. In that case, we can say current dot add I minus 1. Right. After we finish all of this, we say res plus equal to current dot size and I don't even need a DP. I just need a previous. Right? I just need a pre. I just need a pre and have a current. That's all I need. Right, so I don't need this. I just need dp, and then I have a current. Current, blah blah blah. That's done. So if this is not empty, yes. Or maybe I can do this, and then we can say if dp is not equal to null. Right, if dp not equal to null, then we don't have to use this, right? And we won't call it dp, I'll call it pre. Okay, pre current, and we say this is pre, and this is pre. Do this. Yeah, not equal to null. Right, if it's equal to null, then we just put a current one in it, and then we do this. Then we say pre is equal to current, and then go to the end, and then we return rest. That shall do. Pretty standard DP solution. Yeah. Standard DP solution. I mean, I can try a few more. Or we can do all A's. Or random and see if it works. Oh, I feel like it's slow though. That's alright. Let's try this. Okay. Looks alright. Probably is not the same as the one I was thinking about. Alright, we can take a look. This is the last time. Previous time. You know what? It's always been the same method. It's always been the same method. I guess this is the same idea, right? From both ends. Extend palindrome. Left and right. While left is logical zero, right is this. And these are the same, so we extend. Left, right, count plus plus. Right, left, count plus plus. Really? Why? It's not thread safe. Okay, fair. Fair. You don't deal with don't deal with design issue when you are handling this. Anyway, expand odd length. Oh yeah, every time you expand, you take one. Every time you expand, you take one. Or even length. Oh yeah, this will work. This will work. What, is this faster? Maybe it is faster. Maybe, because you don't have to set up a new stuff. You know what? Let's try this. Let's try this. So this basically is so this method is inspired by it takes one caret char from S and try to expand on both sides. Whenever a palindrome shows up that way, we increment the count. Okay, so I'm gonna basically do the same thing, right? Alright, private int count expand palindrome. We'll have, okay, I'll pass string, and I need an int left and an int right, and then we start, and then we'll return a count. So we say int count is equal to 0, and then we say while left is logical to 0 and right is smaller than start length, and s.charat left is equal to s.charat right, and we say awesome. We say left minus minus, right plus plus, and count plus plus. Right? Try to count how many we have in this case. And then once we're done, we'll return count. Okay, now to use this function, what we do is int res is 0, and then we just go through for int I, 0I, s dot length, I plus plus. Then what we can do is res plus equal to expand palindrome s, right? And this is going to be I. This is going to be I, right? So this is odd length palindrome, right? And we have also res plus equal to expand palindrome. I have no idea what I did. Oh, I had example. I have one example. Expand palindrome s, and then this is I, and we do I plus 1, right? So this is even length palindrome. Okay, once we're done, we'll return res. Something like this. Let's take a look. that's actually not right. I think I'm missing something. Yes. Okay, let's take a look. Throw a bunch. Nice. This actually might be faster. Yeah, it's much faster. It's 2 milliseconds. Okay. Now this is faster than solution 1 because there is no overhead of creating array list. There we go. Good problem. All right, let's move on. Shortest string that contains 3 strings. Given A, B, C, your task is to find a string that has the minimum length and contains all 3 strings as substrings. If there are multiple, return the lexicographically smallest one. Return this string denoting the answer to the problem. A string A is, okay, I know this. So ABC, BCA, and AA, we need to find something that has the smallest substring. So basically, we need to find a way to overlap these 3, right? Need to overlap these 3. And it has to be a prefix and suffix kind of overlapping. So what we can do is, A, AB, ABBA, ABAC. Okay, so AB, so there's 6, I think there are 6 different ways to match them. So we can do AB, we can do ABC, right? So AB and then BC. Oh, hold on, we can do AB, AC, and BC. And each one we can do BA, CA, and CB, right? Then we can match them. So we can do AB, we can match C, right? We can do BA match C. That's it. We can do AC to match B, or CA to match B. Or we can do BC to match A, or CB to match A. That's it. It's just like a permutation, right? ABC permutation. 3 factorial is 6. So we have 6 different ways to concatenate. And we're just trying to see which way is the best. We can brute force this, honestly, right? But the question is, how can we brute force this? So in this case, it's A and B. So A is one ABC, B is BCA, right? How do we concatenate them? That's a good question. How do we overlap them? Basically, we need to count this way, and this also counts. So we find this, right? We find B, and we just go to the first one, right? And then because I can do this, I can get 6 of them, right? And then what will be the best way to overlap them? So one of them will start from the front. So I can say go, we find the first B, okay? Then we move on to find C, is it? If it's not, then we reset to the first, go, and we try to find, the most overlapping, because it has to be overlapping. It has to be overlapping, right? It has to be overlapping. So if it does not overlap, like if we have something here, right? And it does not equal, then we cannot. It does not match, right? Does not match. And the thing is, if you find AB and you find BC, then you shall be able to do ABC from, like, I have AB, right? And I have, so AB is this ABCA, and BC is going to be BCA, AA. So when you find these, right, how can I get these like easier to match these? Well, because once you match AB, right, you match AB, you know it must end as a B, right? It must end as a B. So you can directly check BC. Wow, that's great. So how should I, so you match AB, you get a value, okay? That's okay. So not only do you get the AB, you also need to get what is additional to A, right? What is additional to A? So we can know what is, so this one, what additional to A is A, right? So it's like on the left hand side is A, right? Additional is A. And for this case, because I know it ends as BCA, so when this one B and C, so what I need to know is after B, what is C? And it's AA is here, right? This is AA. And in this case, actually, no, it's after A, what is additional to B? So this is A, that's the additional. So AB, what we get is AB, ABCA, ABCA and A, okay? BC, what we get is a BCA, BCAAA with an AA. So now if I merge AB and BC, I know all I need to do is just to add the last AA. So now we have ABCAAA. So that's what it has, right? That's what it has. So not only that, we need to find the shortest, right? The shortest, and also, I mean, we can have a mechanism to do that. That's not hard. The hard part is still the mechanism of configuring them. I mean, I can just do AB, right, and BC, AC. I can do all of them. Like we do AB, we get AB and BA, right? We get AC and CA. We get BC and CB. We get all of them, right? We get all of them. And once we get all of them, I need to. Now, how do you know AB? Or you can say, I want AB. I do AB. Then I immediately do this with C. And then I do BA, right? BA, I immediately do C. So this I also did AC as well, right? And now I do AC. And I immediately go for a B, a CB. So I go for a B. What would be the easier way to handle this? It is brute force, but it gotta be easier on the brute force side, right? I mean, we could just, like, seriously, brute force it, right? don't have to worry. But then it's not efficient. Actually, if you look at this, right, AB is ABA, that's the mass, and BC is BABA. And if you want to match these two, you have to rematch them, right? You have to rematch them. It's ABABA. Maybe we do have to just brute force it. Well, I don't see another way. We have to brute force it. We write a function to merge the two, right? And then we just, go through all these different ways. And how do we represent these ways? What I can do is permutation, right? Do we have a permutation in this? Or, I mean, we don't have to permutate, right? We don't have to permutate. We can just do, I can do, I actually don't know. It's, 2, 3, 4, 5, 6. That's not true. Let me think. What would be the best way to represent this permutation? We can just do that. We just write this out. We can write this out, and then, just do it. Yeah, I don't see why not. Like, seriously, I don't see why not. We can just do that. There's only 6. Okay. I think I'm convinced. I'm just gonna brute force this. Very rarely we can brute force a problem. All right, so we are brute forcing this problem. Okay, so what do we have? We have we have a string. Result is equal to this. That's fine. And we just say we need a function merge. Okay, so private string merge string A and string B. So we merge these two. Okay. So the way we merge is pick the first and the B, and now we go in A. And until we are good, we just add the remaining to it. Okay. So basically we say I mean substring, if we do substring every single time, that is going to cause an issue, I suppose, right? I suppose. So you're not doing substring. But the easiest way is to do substring, right? We can say for I0, I smaller than a dot size, length, I plus plus. If a dot substring I, right, if that's equal to, actually string, I cannot do this, right? So we can say string dot equal. Actually, how do we compare two strings? I forgot. It gotta be a dot equals. Dot equals. So we can do if a dot substring this dot equals b. Okay. The first time, then we can return. Okay. Actually, no, that's not true. It's not the entire b. Okay, it's not the entire b, it's the prefix of b. So it shall be a dot substring is equal to b dot substring. Actually, I'm not sure. Do we have this? We don't. So substring have a beginning and end. Okay. Yeah, that's the thing. It doesn't show. Like, what the hell? How can I see the... Here we go. That's not the one I was looking for. Okay, here's the one. But how do I D P? No, this is go up and down. B? No. Control F. Okay, F and D. Yes, F and D. F and D. Okay, so. Okay, so it does not include the end index and extend to the character index. Okay, so okay, I got this. All right, what the hell is this? All right, so that's gonna be from 0, right, all the way to so I to the end, right? I to the end. What is the length? Length is gonna be a dot size, a dot length, okay, minus I. So 0, 1, 3 minus 1 is 2, right? So the length minus the index will tell you the size. So now for the b is just going to be this, okay? So if these two and the first time these two are the same, okay? If the first time these two are the same, then what we're going to return is, oh, I don't want to do it twice. So string sub a is equal to, so I'm going to delete this. Right, this is sub a. String sub b. For b. Okay, so sub A, sub B. So if sub A is equal to sub B, what about the length? What about the length? The length cannot be larger than, right? So A length minus, so it'll be too big. So it has to start with the size of B, right? The size of B. Therefore, the starting position shall be the length of A minus the length of B, right? Minus the length of B. If the length of A minus the length of B, if A is bigger, then we need to start from if A is smaller. Yeah, so we do the maximum. So hold on. What we're gonna do here is mass dot maximum 0 and A dot length minus B dot length. Right? Is that right? A dot length minus A is bigger. So A if it's 5, if B is 3, then we start with 2. 1, 2, 3, 4, 5, 0, 1, 2. I think that's correct. That A is 5. If A is 5, B is 2. Right? A is 5. And B is 2. 5 minus 2 is 3. So we start 0, 1, 2, 3. We start with 3. Because 3, 4 will match the B. The B only 2. So we do that. And that way we'll return sub A plus, right? Sub A plus B dot substring again. That's gonna be A dot length minus I to the end, right? So we do that, but if there's nothing, right? If there's nothing, like substring didn't find anything, then we'll just return A plus B. Okay. So what we're gonna do is just do it 6 times. Right, we'll do it 6 times. And then string S1 is equal to we say merge AB, right? And then we say merge right C. We do that. Yeah, can we I think we can. We can say string this SS equal to new string, nope, string A, B, C, right? I can do that. And then pattern, right? Pattern, just basically a pattern. Or we can do permutation on it. Yeah, this feels wrong, you know, it just feels wrong. Pattern for okay, pattern, go to new int, right? We can say 0, 1, 2, okay, 0, 1, 0, 2, 0, 2, 1, and then 2, 0, 1, and then 1, 2, 0, and 2, 210, right? These are the pattern. Okay, this is the pattern. So now what we do is for int p of pattern, right? String s equal to merge p0 p1 and p2. Okay, and now we say if res is equal to null. Yeah, I'll start with null. Right, equal to null, or res dot length is smaller. No, s dot length. We can say larger than s dot length, or if s dot length is smaller, right? What if s dot length is larger? Or res dot length is equal to s dot length. And can we compare string lexicograph? How do we compare that? Compare to. Okay, compare to and res s dot compare to res, right? If that's smaller than 0. Okay. So if these are, then res equal to s. And then at the end, we will return res. Oh! Oh, yeah. How is that happening? That is absolutely unacceptable. Error cannot convert to string. Oh my goodness. My bad. I forgot. SS this. SS this. And SS this. Then why do you do SS? It doesn't make any sense. It does not make any sense. You know what? Let me do this one more time. I'll just do pattern. You don't have to do this, right? I'll just do pattern. It doesn't make any sense. Right? Why? Exactly, why? I can just do string here, and then we do string here, and we just do ABC. Right? We can say, you know, all the 0 is A, so we say this is A. Ugh. So next dot. Alright, and then I can say, or find all the ones. 1 will be B, so next dot. And then we say find all the 2s, and they will be C, and say next dot. Right, and then of course this is not, it's gonna be a string, and then we just do this. Yep. Does it work? All right, that is weird. The first one, output AAA. That how is AAA? The merge doesn't work. All right, we need to do it slowly. All right, let's do it slowly. Let's maybe we should do it here. Let's say system.print.out print line a plus, I don't know, let's do /b, okay, and then system.out.print line. We'll print this one. Or we say system.out print line a plus b. Okay. Run this, take a look, and decide what went wrong. So A, B, C, and BCA, we return BCA. That is wrong. Oh, because I do sub A, my bad. It should be A. Okay. That was the error. This one should be right. Yeah, it should be A plus this. There we go. Okay, so now we're gonna remove all the printout. Okay, then we're gonna run this, and yeah, is it the most efficient? No, but it's a brute force. Oh, it is wrong. Holy crap! How? CA. Oh shoot. Substring. Oh, I forgot. Yeah, it's substring. Ah, I just hit my toe. Oh. Has the minimum line that contains all three strings as substring. Oh, it doesn't have to. Oh, I was just thinking one of the possibilities, right? To merge them. Yeah, that is one possibility, is to merge them. Well, another one is if one of them contains the other. If they contains the other, then you don't have to merge. If nothing contains the other, then that's why you need to merge. Makes sense. All right. If it contains, then if it doesn't contain, right? But still, if it doesn't contain, why do you always want to merge them? You can put it like in the middle. Huh. Hold on. So it has to contain, right? So we can actually start with something at the base. I'm thinking about using a completely new method. So something has to be the base, right? And then based on this, you can start creating. You can start creating. Oh. I mean, trying to merge is definitely one way. Can we just say this? If someone contains the other, then I cannot say that that's always the good way, right? merge. And the shortest one that contains some might not actually be the shortest one that contains them all. We should have a tag here. Lovely, awesome green. Okay, one feeling fabulous. So let's nail some limitations. All right. Oh, cats. Let's start me on. Alright, I'm back. So yeah, merging it's not working because they could be have a contain relationship. So maybe what we need to do, can we just set one of them as the base? You know, we set one of them as the base, and then we just try to put the other one in it. And the other one you want to put in it, it can be, because you cannot break this up, right? So the other one put in it, we can try to merge on this side, merge on this side, or if it's already in it, right? If it already contains in it, perfect. We don't have to do it. Otherwise, we merge on this side, we merge on this side, right? And then we create a new string, and the last one is the same. We try to merge it, or we put on this side or this side. And now that's a pattern of ABC, right? And we can also have A and CB, right? We do this and this, or we can do a B at the center, and then we try to merge A, right? We try to merge A on this, or try to merge A on this. But isn't that the same as this? I mean, in this case, we might be duplicating, right? We say A, we can merge B here, or we can merge B here, right? And then from this, actually, let me draw it the other way, maybe easier. So we say A, so we can do A and B, or we do B and A. And this we can do A, B, and C, or we can do C, A, B. This is B, A, C, and this will be C, B, A. So by doing this, we handled everything that, we actually handled a lot, right? We handled a lot. And then we can have A, we can do C, right? CA, and this is ACB. B out here, so it can be BAC, and this will be CAB. This can be BCA. Oh, this and this. Yeah, it's already handled. And this is not just to put on the side, it's also to merge. So maybe it's the thing of this merge function. Instead of merging like this, we have to also check if A contains B, right? If A contains B. How do I check if it's a substring? Check if string is a substring. Contains. So maybe all we need to do is say if A dot contains B, then we just return A. Like that. Let's see if this one agrees. There we go. All right, just brute force. A little bit brute force. I just didn't consider the other condition for brute force. Once we consider the other condition, problem solved. All right, deserve to take a look. 6 possible merges. Jesus Christ. Only 3. Come on, man. Just check all the permutations. Yep. I'm not gonna compute. There's only 3, so it's fine. I mean, you will have permutation that's actually 6, right? Because we only have 3. So 6 times, then we have 2 merge, right? So each merge is n squared, right? Each merge is n squared. So 6 times n squared, right? 6 times n squared. But anyway, I think it's all right. It's not too bad. It's not too bad. Okay, so I probably want to read this problem so I can have this in my mind. Or maybe not. Maybe we do it tomorrow. Okay? Alright, that will be it for today, and I will see you guys tomorrow. Adios. Adios.